Okay, so in this question, what we have is we have a person. They are standing on a bridge, maybe, and they're going to jump off the bridge. So that's 10 meters. And over on one side is a truck, and it's traveling at a constant 50 kilometers per hour, and it's going to this way. So our ultimate goal in this question is to figure out how far the truck has to be when the person jumps. And then what will happen is the truck and the person will meet. So this question is actually two questions. The first part, it has to do with the person, and then the second part has to do with the truck. So the way I would break this question down is I would look at all the characteristics that just apply to the person. So let's look at those now. So the first thing to realize is that they're basically falling from rest. So their initial vertical velocity is 0. They have a change in displacement of -10, and they're accelerating due to gravity of -9.8. And then for the truck, it has no acceleration because it's moving at a constant 50 kilometers per hour. But because I want the units all to be kind of in agreement here, so instead of being kilometers per hour, we can convert that to meters per second. And the way we do that is we divide by 3.6. Now, I like to keep things in terms of up and right, usually. In this case, I'm kind of doing a little bit of a mix of both. So I have, instead of saying down, I'm saying -9.8 up. And then the delta is -10 up as well. So what do the truck and the person share? Well, the thing that they share is time. The time that the person takes to drop to the ground is the same as the time it takes the truck to get to there. So that's what we're looking for. The delta t for the person is the same as the delta t for the truck. And ultimately, we want to find this, our delta dx. So we know the most about the person. So my strategy is if I can find the delta t of the person, then I know the delta t of the truck, and that gives me one more piece of information, and then I can use that to solve for delta dx. So to find delta t for the person, I'm going to use a motion equation. Specifically, I'm going to use delta dy is equal to VIY times delta t plus half a delta t squared. That's a 2. And then I'm going to substitute my variables here, -10, that's 0, plus a half times -9.8 times t squared. Multiply both sides by 2 to get rid of the fraction. Then divide both sides by -9.8. And then ultimately I'll take the square root, and my answer becomes 1.4 seconds. That's equal to t. Now, what we do is we use that information and we find delta d. And we're going to use the same formula, but the exception is that this term actually goes to 0 because there is no acceleration. So therefore, we just left with these two guys. And that makes a lot of sense because to figure out the distance that something goes, we just take how fast it's going, which is Vx, multiplied by the time it takes to go that distance. So in this case, I have 13.9 multiplied by 1.4, and that's equal to 19.9. So, therefore, the truck is 19.9 meters away.